quartile deviation and mean deviation and standard deviation. See here, the range of quartile deviation and mean deviation and standard deviation in relative measures of dispersion of independent of the units of the measurement. For comparing the variability, even the distributions are expressed in the same units. The relative measure of dispersion is computed. The relative measures of the ratio of absolute dispersion and an appropriate measure of central value and is expressed as per page as a pure number. These measures are also used to compare relative accuracy of the data. The most commonly used relative measures of dispersion: coefficient of variation, coefficient of quartile deviation, coefficient of mean deviation. Of these variation, quartile and mean deviation, we are taking here. Measures of central tendency. Distance is the average of the second order. Useful in the giving the detailed characteristics of the observation establishing with the in where we now briefly introduce the measures of dispersion we are taking here. What is the range? The range is a symbol of measure of dispersion. The value of the range depends upon the extreme values of the data. L denotes the large value of the distribution, and S denotes the smallest value of the distribution. Then the range of the distribution is defined difference between largest value L minus S. We can take largest value minus smallest value. We can take that. That is the range we have taken here. Coefficient of range. The coefficient of range. The coefficient of range we are taking here. So that is range means we are writing L minus S large and small value. The coefficient range is L minus S by L plus S. We are writing here. So merits of the range. So what is the merits of the range? Range is the simplest measure dispersion. It's easily understand, easy to compute. It is rigidly defined. The units of range of the same units of the variable is it takes minimum time to calculate. It gives a throw. Rough answer range is useful to studying weather conditions. In quality control of manufactured products, ratio study the variation of quality in the manufactured. Range is used variation in the variable or not much. It is measurable dispersion, which is used to be standard variations, gold price, etc., share values, money rates. So whether the forecasting of the meteorological department, that they all these ones taking the units. Then find the range and the coefficient of the range of the following data. Find the range and the coefficient. What is the range? See here 180, 210. This is not given in ascending order. This is a random order. So 180, 190, 208, 210, 225, 260. I am given the ascending order. Highest value is 260, the lowest value is 180. The range is 260 minus 180 is 80. And the coefficient we have to find it. The coefficient is L minus S by L plus S. L minus S by L plus S here 260 minus 180 by 260 plus 180. This is 80 by 440. We can calculate by 80 by 440 0.18 and 18. We are taking here. Another one example, the x and f frequency given here. Here highest value is 60 and the lowest value is 10. So 60 minus 10 is equal to 50. To calculate the range of distribution. So we did not take the frequency value. We can take the only x values we have taken here. Then another one, find the range of the following distribution. Intervals given here. Highest interval 30. Lowest interval is 0. So highest interval 30, lowest. So 30 minus 0 is called 0. So this is the interval process also we are doing here. Interquartile range. What is interquartile range? The interquartile range is defined the difference between the third and the first quartiles. Interquartile or Q3 minus Q1. The interquartile range is the measure of variation. Building block box plot when the data is skewed represents pair better than the other measures of the dispersion we are taking here. Quartile deviation. What is quartile deviation? Quartile deviation here. Quartile is absolute measure of dispersion. It is defined as follows here. The quartile deviation is distribution defined as the difference between the third and the first quadrant, symbolically Q3 minus Q1 by 2. The quartile deviation known as the semi-interquartile range. So Q3 minus Q1. So coefficient. This is the Q3 Q not normal definition. Coefficient means Q3 minus Q1 by 2, Q3 plus Q1 by 2. In the range also we can take that L minus 1 by L minus S by L plus S. Here also Q3 minus Q1 by 2 by Q3 plus Q1 by 2. 2 to get cancelled here Q3 minus Q1 by Q3 plus Q1 L minus S by L plus S. Also in the deviation we are taking the quartile deviation we are taking here Q3 minus Q1 by Q3 plus Q1 we are taking here. కొంచెం నాకు ముఖ్యం తప్పదు నన్ను కూర్చొని క్లాస్ చదువుతావా క్లాస్ అయిపోయి మన తింటావా when the quartile deviation the coefficient of the quartile deviation from the following data 41 34 52 42 37 61 58 71 64 69 74. So arranging the data in ascending order. So ascending order we are taking the data here 34, 37, 41, 42 also there here. Then 52, 58, 61, 64, 69, 71, 74. I am written this ascending order. So total size 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So n plus odd number n plus 1 by 4, that is 11. Third 12 by 4. So 11 plus 12 by 4 means third item. 12 by 4 means third item. Third item means how much? 41. Q1 is 41. Q3 size 3 into 11 plus 100. 3 into 3, 9. 9 means 1, 2, 3, 4, 5, 6, 7, 8, 9. That is 69. So 69 minus 41 by 2. The quartile deviation first we are finding. 69 minus 41 by 2, that is it is equal to 4. So coefficient means 69 minus 41 by 69 plus 41. 28 by 10 to 110, that is 0.255. That is another method. Now the quartile deviation, we are taking the range quartile deviation of the following data we are taking here. And quartile deviation range and deviation, we are filing the marks on the number of students 25, 30. See here, I am taking the diagram. Just a minute. 20, 30, 40, 50, 60, 70, 80, 5, 9, 16, 2, 4, 3, 1. 20, 30, 40, 50, 60, 70, 80. 5, 9, Here wrong given. That is a 16. We check that one. 12, 4, 3, 1. 5 plus 9, 14. 14 plus 15, 29. Here correct. Here we have to change 15. 29 plus 12, 41, 41, 45, 48, and 49. We are taking that value. Where n is equal to 49. So why we are taking the 49? The total value is cumulative frequency 9, and n plus 1 means 49 plus 150. We are taking here n plus 150 by 4 is to 12.5. 12.5 means 12.5, 3 into n plus 1 by 3 into n plus 1. So 50 by 4 and 12.5, 12.5 into 3, 37.5. So 12.5 means that is 13th item we are taking here. So 13th means we are taking the value here. The frequency is 30 here. So this is the value we are writing here. So Q1 is equal to 30. So 37.5, there is no 37.5. There is highest value is the 41st. 37 is less than 41 items, so we can take the frequencies. 41 is Q3, therefore Q3 is equal to 50 value we got. So here we are only 29 is the 49 is 41 is there. So 41 is there. So the 41 is under the comments of the 50 we are taking. So Q3 is 50. The quartile range is Q3 minus Q1 is equal to 50 minus 30 by 20. 50 minus 30 by 50 plus 30 is equal to 20 by 80, that is 0.25. Another example I am taking here. Calculate the quartile deviation from the following: 30 minus 32 by 12, 32 minus 32, 4 by 18, 34 minus 36 by 16, 36 minus 38, 36 to 38, 12, 40 to 42, 8, 40 to 44, 6. The given range given here. So, same total values 12 plus 18, 30, 46. I'm checking here. 12, 30, 46, 60, 72, 80, 86. Total value is 86. When n is equal to 86, 86 by 4, formula is n by 4, 21.5, 3 into 21.5, 60. So 64, where 64 here? So that is taken that the 64, 21.5. So we are taking here 30 to 34 interval where. So this is a and clear the drawings here first of all. So 24.5 means 30. We are taking at the class is 30 to 34. Then the 64.5 means, so that is a 38 to 40, 64. Above 60, that's 72 under the 72 class here. So 38, 40 we are taking here. The lower limit is first one 32. The lower limit is 32. So therefore, the summation of 32 and total summation of is 36. Cumulative frequency is 12. Class frequency is 12. 12. Why? Because 12 is the basic cumulative frequency. Q1 class above Q1 class 12. So Q1 class is 18. We are written here. Q1 class is 18 here. The width is 32 to 34. That is the width is every class interval is 2. So formula is Q1 is equal to L1 plus N2 by M1 by F1 into C1 into 32. So lower class is 32, higher is 10 by 2 is 21.5, M1 is 12, the frequency, and 18 into 2, form class interval is 2. So the finding is 33.6, and the lower middle interval 36, 38, 86, and all these class interval 38.7. So quartile deviation formula 38 minus 75 by 38.306. 5.69 is equal to 2.85. The value is we are writing here. So demerits of the quartile deviation. What is the demerit? Quartile deviations and demerits. So demerits of the quartile deviation, we are taking a quartile deviation is a positionally average, therefore they are not amenable to further algebraic treatment. It ignores first 25% of the items, at least 25% of the items. So the value of the quartile deviation is affected by sampling fluctuations. So see here, this is the values we are. What is the basic fundamental of mean deviation? What is the mean deviation? Now quartile deviation is over and range is over. Range. Mean deviation is absolutely a figure. It defines the arithmetic mean of the deviation of a series of computed from any measures of central tendency, uh, provided the deviations are taken non-negative. Mean deviation is denoted a letter delta. We usually compute a mean deviation about mean one of the three averages, mean, median, or mode. Some cases mode may be ill defined. So we can write the mean deviation of ungrouped data. Ungrouped data means individual series we are taking here, x1, x2, x3, x4, and so on, xn. Denote n observations. The mean deviation of the deviation is summation of x minus by x bar by n. And the mean deviation of the median x minus xi minus me by n we are taking here. So we are finding this one. The mean deviation for group data. So the mean deviation for the mean deviation for group data we are taking here. So mean deviation is the discrete series x1, x2, xn. So denote n observations we can write here. Summation of from some see here. Summation of f of x by x minus x bar by n. And the mean deviation about the median mi is summation of f of x xi minus me by n. N is called summation of. Similarly, we can also define the mean deviation about the mode. Mean deviation continuation series. So discrete group data continuation series also. See here, continuation series also same. Summation of xi by x minus me by n. So in play x minus xi by n. In the mean deviation, the median also we can write summation of xi minus me by n. So there is no change when the denote series that there is x1, x2, f1, f2n. The mean deviation of continuous series and group data is also same here. So coefficient of mean deviation. What is the coefficient of mean deviation? When mean is 0, the coefficient of mean deviation by x bar. In range, we are taken that L minus S, and the coefficient is L minus S by L plus S. In quartile deviation, Q3 minus Q1 by 2. So coefficient is Q3 minus Q1 by 2 plus Q3 plus Q1 by 2, Q3 minus Q1 by Q3 plus Q1. Here coefficient of mean deviation is called mean deviation by x bar. That is average. So now I am finding the one. Find the mean deviation of the following data: 34, 36, 37, 39, 40, 41. So this is ascending order. I am taking the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So total values I am some addition చేస్తున్నాం. 400 by 10 is equal to 40. See here 34. 34 minus 40 minus 6 x minus x bar 6. 36, 44. So here we take it. So negative value should be the positive value. 38 minus 42. 13, 41. 40 minus 40, 0. 41 minus 40 minus 41, 1. 43 minus 43. 44 minus 4, 44. 48 minus 4. So the total is 32. So if negative value is there, also we can take the positive value. So output is the total value by the mod x bar is equal to 32. We can write here. So therefore, the mean deviation is x bar is equal to 32. How many numbers here? 32 by 10 is equal to 3.2. We can write as per the mean deviation of the following the series of the equal series, the discrete series. We are writing here. In compute mean deviation of the given below, x f1 2144 6684 101. So 21446684 we are taking here. 246810 14641 we are writing here. Fx 21 into 2 41 into 4 4 the 16 36 8 4 the 32 10 5 4 10 11 12 13 14 15 16 total 18 18 24 34 35 46 54 74 94 94 correct. So xi minus x 2 minus 1 1 2 minus 4 minus xi minus x bar Just a minute, I'll clear the drawing and I will explain. Here x bar here under. Okay, just a minute. X bar we are finding here. X bar means total. This total is 96. 96 by total is 16. So that is 6. So we can take here 2 minus 6, capital 4 plus 4. 4 minus 6, 2. 6 minus 6, 0. 8 minus 6, 2. 10 minus 4. So modulus means we are multiplying. So f of 1 into 4, 4. 4 into 2, 8. 6 into 0, 0. 4 into 2, 8. 1 into 4, 4. Total 24. So 24 by 6, that is 1.5. We can write here. Find the mean deviation of the following data from the arithmetic mean. 0 to 5, 5 to 10, 10 to 15, 15 to 20, 20 to 25, 25, 30, 32, 35. 2, 7, 10, 12, 9, 6, 4. Here we have to take the total. 9, 19, 20, 31, 40, 46, 50. Correct. So midpoint is 2.5, 7.5, 12.5, 17.5, 22.5, 27.5, 32.5. Correct. So what is the frequency multiply? This is 5. This is to 55, 125. We are multiplying these two values here. The total is 890. X minus X bar. So X minus X bar also we are finding here. 890 by total number 17.8. So we can take the 72 minus 17.8. So 72.5 minus 17.8, 15.3. And also 7.5. 7.5, 17.8, 0.3, 12.5, 17.8. So all the values we are here. F into XA also we are multiplying here. 5 into 3. This is wrong for 15 5. So this is you have to cross check. 15.3 into 5. 15.3 into 3. 5. 15. Just a minute, I will calculate and tell you. 15.3 into 5. This is the wrong 76, 10.3. F into XA. 2 into 15.3. 30.6, correct? Then 7 into 10.3. 72.7 into 10.3. Here wrong. This is 72.1. You have to come this way 73.3. 10. 10 into 5.3. 53, correct? 12 into 0.3. 3.6, correct? 9 into 0.7. 9 into 0.47. 4.23. 4.23 is the wrong here. Your 0.47, 4.7. 4.23, correct? 6 into 9.7. 58.2, correct? 4 into 58.8. The total is 318.6. Total number is 50. 890 by 50 is another one, 318. 38.6 by 50. 6.73 to 6. Mean deviation is 6.32 by 17.8. That is we are writing here 0.36. So measure merits of the mean deviation we are taking here. Mean deviation is a simple measure of dispersion. It is easy to understand and easy to calculate. The measure of is less affected by fluctuations of sampling. It is based on all items of the data and it is given weightage according to their size. Mean deviation is rigidly defined a measure of variation. It can be used for comparison. It is less affected by the extreme values of the data. Demerits of the mean deviation. So merits and demerits of the we are taking here, demerits of the data we are taking here. Mean deviation is not accurate measure of dispersion. It is not suitable for the further mathematical calculators. Mean deviation is calculated for median yields better. The availability is so too high. While computing mean deviation, the single sign of the all deviation taken as non-negative. Use of mean deviation. Mean deviation is using useful marketing problems such as income and this is the this how to do all these problems in some. Then the measure of dispersion too. So in the measure of dispersion too, also we are taking the standard deviation, skewness, and Carl Pearson method. We will take here. Now the standard deviation. So standard deviation is sigma. Standard deviation is defined as the non-negative square root of arithmetic mean of the square of deviation of the items observation from their arithmetic mean. It is called the root mean square deviation. It is denoted by the letter they already told or read sigma. There are two methods of the calculating standard deviation. The first method, we consider the deviation from actual while computing the standard deviation. In the second method, we calculate the standard deviation by the taking of the assumed mean. In general, we define a symbolic form a standard deviation as follows. Standard deviation of individual series that x1, x2, xn is denote the n values. Taken the random variable we have to take here. Sigma is equal to under root of summation of x1 minus x bar whole square by n, where x is arithmetic mean and n observations, there x1, x2, xn we are writing in. Alternatively, the above formula to finding the standard deviation can be written as sigma under root of summation of xi square by n, that is modulus of x whole square. So d is equal to x minus a, we take the standard deviation, summation of dA square by n by within the bracket d bar whole square. So d bar is equal to summation of dA by n. Standard deviation of the discrete data. In x bar, the actual mean of the series, the standard deviation is calculated by the formula summation of fi dA square by summation of fi. So we are taking here di is equal to x minus x bar. So x bar means xi is the discrete series we are taking here. So summation of f of I x minus x bar whole square by summation of f of I. Sigma is equal to under root of summation of x minus x bar whole square by n, we are writing this one. So totally di x minus xi denote the discrete series here. The summation is standard deviation under root of summation of fi di square by summation of fi minus summation of fi di by summation of fi whole square into c. The rating here d is equal to xi minus a, where c is the common factor we are writing here. So standard deviation for continuous series we are writing here. X bar is the actual mean of the series. The standard deviation calculated by the formula we are taking here. X bar is the actual mean of the series. The standard deviation is calculated by the formula sigma is equal to root of summation of fi ds square by summation of fi. So dA is equal to xi minus x bar. Xi denotes the midpoint here. The class interval denotes the assumed mean of the series standard given by summation of fi dA square. Summation of phi minus summation of fi dA whole square by summation of phi dA is equal to xi minus a. We are writing here. Xi is the midpoints of xi is the midpoints of the class intervals. In the step deviation, the standard deviation of the computed the formula rho is equal to summation of fi dA square by summation of fi minus summation of fi dA by summation of fi whole square. That is the condition equal to xi minus c. common factor usually size of the class intervals we will take here. Then coefficient of the standard deviation. Coefficient of the standard deviation is the value of rho by x. Variance is the sequence variance. Coefficient of standard deviation is given by sigma by x. Variance is the square of the standard deviation divided by b or sigma square. The coefficient of the variance is defined by sigma x into 100. In the standard deviation of the mean error, the standard error mean is the standard deviation, that is sigma by root n we will take here. The merits of the standard deviation. The standard deviation is rigidly defined. It is based on odd ends. It possesses almost all the required characteristics of a good measure of the dispersion. It is a stable measure since the measure is less affected by the fluctuations in sample. It is amenable to algebraic treatment. It is difficult to calculate standard deviation. Demerit is not. It is not understood. The measure of give the more weight extreme items is an absolutely measure of variability. They cannot be used in the purpose of the comparison. Standard deviation is widely used in statistics. The measure of helps the standard error determine the difference between the means two similar samples by the chance or real. Standard deviation is useful assessing the degree of dispersion around its mean. So find the standard deviation of the data given below. 25387 here. So 2 4 5 is double 25, 3 9 8 64, 29, 5 8 8 16 25, 25 29 30 30 38 42 42 102 102 50 150, that is 151. So summation of xi by n is equal to 25 by 5, that is 5. So 151 by 5, that is 5, minus formula x bar is equal to 5 whole square. So 25, 151 by 5 minus 25 is equal to 5.2. Compute the standard deviation for the following data: 10, 5, 2, 10, 15, 16, 18, 5, 28. So we are taking the values here. So 10, 5, 2, 10, 12, 20, 15, 16, 18, 5, the given values here. 5, 10, 6, 5, 8 we are writing here. So 10 into 5, 50, 12, 120, 90, 18, 5 is a 90, 21, 6, the total is 34, that is 510. Xi minus x bar. Xi minus x bar means total is 510 by 30 to the 15. So xi is 10 minus 15 minus 5. This is not a modulus, so the minus values we are writing here. Minus 5 minus 8 plus 8, the value is 0. Xi minus 25, 5 is a 25. 3, 3 is a 9 here. That is wrong interpretation. 0, 3, 3 is a 9. 5, 5 is a 25. So 25, 9, 34, 34, 43, 43. So f of x minus 460 by 34, that it is totally 3.678 we are writing here. So another one, calculate the standard deviation of the following data we are taking here. 95 to 105, 105 to 115, 115 to 125, 135 to 125 to 135, 135 to 145, 19, 23, 36, 70, 32. So the class interval is between the class interval is 95 to 105 and all the class interval is 10. So highest 135. Let us assume the mean is here. Let's assume the mean here 130 xi minus c by the following data. Here we will take the so 95, 105, 105 to 115, 112, 125, 125, 31, 35, 145. 19, 23, 36, 70, 52 is equal to 200. Midpoint is that is 100, 110, 120, 130, 140. So xi minus x bar also we are taking here. The value here xi minus a. Xi minus a c is equal to di. Already we have written here a is 130. 130 here xi is 100. 100 minus 130. 30. 30 class interval. Class interval 10. 130 by 3 minus 3 minus 2 minus 1 0 1. So FID. FID 19 into 3, see 57, 23, 46, 36 minus 36, 70 is 0, 50 to 52. All FIDs with positive value that is 51. The coefficient of 351 by 200, we will take here 80 minus 87 by 200 is going to 12.89. So another one compute the Compute the coefficient of the covariance of the data of the 20 items whose mean 5.12 and standard deviation 12.81. 5.12 is the one and 2.81 is another one. So 2.81 by 5.12 is equal to 54.88. And the standard deviation of the data 20 is 2.24. The 2.24, the summation of 2.24 by root 20 is equal to 0.501. Skewness. And then in the mean, median, mode distribution of the real random variable exists of fall up at point, then the distribution is said to be symmetrical. In a symmetrical distribution, the variance, the equidistant of the mean will have the all frequencies here. A symmetric distribution or normal distribution in the graph should be held. The two sides of the graph will be the symmetrical mean, and the symmetrical distribution mean, mode, and the cosine, the median be of the quartiles. But it is observed that the most of the distributions are not symmetrical distributions. So in the sense, sometimes the values are valuable to tend to occur regular frequencies. The main median mode, the measure of central tendency occur different points. So distributions are not symmetrical. The distribution which is not symmetrical is said to be asymmetrical distributions. If the distributions are symmetrical, part of the histogram on the left side held. So therefore, the distributions are two sides will be not the mirror image of each other. True symmetric distributions are also called as the normal distribution. The curve and the symmetrical distribution shown in the given below here. We can show here, this is the skewness, x is equal to mode, the curve of the symmetrical distribution. The skew is the tendency of the distribution depart from symmetry is called as skewness also. Positively skewed and negatively skewed we can write here. So negatively means we are writing it is slow. The positively is it's the right side is positive, the left side is negative. We can write here. Skewness of the distribution measured by coefficient of the following methods are the measures of the coefficient: Carl-Pearson, Bowley, Kelly, and method of moments. So Carl-Pearson method. In the Carl-Pearson method for computing the coefficient of skewness and gives the formula SKP. S means SKP. Formula is x bar minus MD by sigma. X is arithmetic mean. MD is mode, and sigma is standard deviation. This is the Carl-Pearson coefficient of skewness. M is called median. So now we have to learn this problem here. The mean of the distribution is 43.71. Right. The mean distribution of 43.71. 51.14 is a medium mode, and the standard deviation is 20.31. See here, Carl-Pearson 43.47, 43.471, 51.54, and 20.31. The output is minus 0.385. Find the Carl-Pearson coefficient skewness of following data 7, 10, 12, 16, 20, 20 to 22, 25. This is in the ascending order there. 7, 10, 12, 16, 20, 20, 21, 22, 25. That is total 153 by 9 is equal to 17. Total is 153 by 17. So 7, 10, 12, 16, 20, 21, 22, 25 right in here. Except minus bar we are taking here. See here all of you. 7 minus 17 minus 10. 10 minus 7 minus 7. 12 minus 17 minus 5. 16 minus 17 minus 1. 20 minus 17 3. 20 minus 17 3. 21 minus 17 4. 22 minus 17 4. 5. 25 minus 17 8 total. So we are taking your whole square here. 10 square 100, 49, 5 is a 25, 1 1 is a 1, 3 3 is a 9, 3 3 is a 9, 4 4 is a 16, 5 is a 25, 8 is 6 to total 298 here. So summation of square xi minus x bar whole square by n, that is 298 by 9 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. That is 33.11 under root of 36 standard deviation under root of 33.11 is equal to 5.75. So 5.75 means here 5.75 where mode of the data inspection by mode 5.75 is 1, 2, 3, 4, 5 means that is 20. Both are 20s here, so both are 20s here, so 5.75 means 20. So 17 minus 20 by 5.75, that means 0.52. And another problem you have to learn here, the sum of the 20 observations is 300. The sum of the square observation is 5,000 and the median is 15. The find coefficient of the skewness here. So summation of x is equal to 300 and the summation of x square is equal to 5,000 they given here. Median is equal to 15 and n is equal to 2 they given here. So summation of x means 300 by n. See here. 300, just a minute. 300 by 20 is 15. Summation of x square means 5,000 by 20 minus x bar is equal to 15. So that is cancel 220 for 250s. 250 minus 225, that is 5. Mode is equal to 3 median minus 2 minus 3 into 15 minus 2 into 15. That is 4 minus 45 minus 30. That is minus here. 45 minus 30. X minus mu naught by 6. 15 minus 15 by that is 0 by something is 0. Another problem we have to learn here. The profit of 70 transportation or source below from the cumulative frequency distribution table. Find Paul Pearson of Q efficiency 8, 20, 50, 64, 70. See here 0, 20, 20, 30, 20, 40, 40, 50, 50, 60, 60, 70, 70, 80. See to 80, 100. 8, 820 minus 812. 50 minus 20. 30, 64 minus 50. Then 70 minus 64, that is 6. 10, the middle 10, 20, 30, 40, 50, 10, 20. Middle 10, 30, 50, 70, 90. Okay. FIXA multiplied here. FIXA multiplied here. 10 into 80, 80. 1 into 360. 1500. 980 for total. Then 60. XI minus a value find out here minus 20 minus 82. So summation of Fi Xi by n, that is 3460 by 70. So that is 49.43. The values I'm substituting here, F is equal to 30, F1 is equal to 12, 41. So total output values I'm substituting, that is 5.59. So standard deviation I'm writing here. Summation of Fi, summation of I, Fi di square by minus summation of Fi di whole square n by whole square into C. Already the values here came here 82. 82 by 70, summation of FIDI square here 82. 82 here, 82 by 70 minus 2 whole square. This is FIDI minus 2 whole square by 70. The total is 21.64. The Paul Pearson coefficient is 14.3 minus 50.59 by 21, that is 0.04. It is positively skewness and negatively skewness. We are writing here. In this unit, we have studied the important measures and also the mean, namely standard deviation, are rigidly defined based on the items of the process because it characters of the good measure of dispersion, stable measure since measure affected by fluctuations. It is amenable algebraic treatment. We also studied standard deviation is called variance of the distribution, and also this is the standard deviation useful in the examination. Any doubts, ask me.